My name is Kyneton Genius, and today we are going to be solving this sample hypothesis testing question. So let's look at this question, and then we see what kind of statistical tests we can use to solve it. All right, let's see. Because the key thing about solving hypothesis problems is for you to understand the question, and then make the right choice, and also be able to extract the right information. So let's start. I'm going to use a pen. It says the professor wants to know if our introductory statistics class has a good grasp of basic math. 6 students are choosing at random from a class given math proficiency test. The professor wants the class to be able to score 70 and above in the test, and 6 students get the score 62, 92, 75, 68, 83, and 95. And the professor have 90% confidence interval confidence that the mean score for the class will be above 70. So if we go to the checklist of tests we have, we can see that in case of z-test, we use z-test when we know the variance of the population and also when the sample size is large. But if we look at this place, the sample size is how many? 1, 2, 3, 4, 5, 6. This is 6. And also for the class, we do not know the variance. So it falls down to t-test. Falls down to t-test. Okay. All right. So what we are now going to do is to let me write it down. So the steps are: first you state the null and the alternative hypothesis. So the null hypothesis is what the professor or what the hypothesis test want to verify. In this case, he wants to check if the class will have a test score above 70. So the current agreed average or the currently agreed score is 70, and we are trying to check if the class will be above it. So in this case, we are going to say is the mean is equal to 70. Okay. So in this case, H1 or HA is saying that the mean, in this case, it says above 70. That is what we are going to check. Is above, is greater than 70. Okay. All right. So the steps you are now going to follow. First, we need to now state the decision rule. And for us to state the decision rule, we need the alpha level. So here we are given the 90% confidence interval, and we have a degree of freedom is simply n minus 1, which is in this case is 1, 2, 3, 4, 5, 6. 6 minus 1 equal to 5. You need degree of freedom in this case. All right. So now we state the decision rule. So in this case, we are going to go to statistical table and then look up the critical value for 90% confidence and degree of freedom of 5. So let's go to the t-test table, student t distribution, as you can see. Let me increase the font of this. So I'm going to go to 90.90 under 5, and that's give us 1.467. So the t critical value is equal to it should be 1.467. 1.467. Therefore, if the absolute value TABS is greater than the critical value, is greater than T-crit, let me just use the actual value, is greater than 1.467, then reject. Actually, this reject is actually fail to accept the null hypothesis HO. Okay. All right. So the next thing we are going to do is to calculate T. Step 4, we calculate T absolutes. TABS is equal to, the formula for it is xi minus x bar, okay, divided by SD times root 10. Okay, so the first thing I normally like to do is to calculate the standard deviation and the mean. So we have that x bar is equal to, in this case, we have 62, 92, 75, 68, 83, 95 over 5. I'll show you an easy way to actually calculate it. Is equal to, all right, so now I'm going to bring up Microsoft Excel so that we can do this automatically using Microsoft Excel. All right, so I'm going to put Microsoft Excel right here so that we can feed this data in there and then use Microsoft Excel. So let's say this is x and this is x minus mean. I can't get x bar, so let's just say x minus, or let me just call it x minus x prime. Oh, is this not coming up? Okay, perfect. All right, so we have 62, we have 92, we have 75, we have 68, we have 83, and we have 95 also. So just go to data. Let me increase the size of this thing so that at least we can see. Okay, so I'm going to put the mean here, mean. So just go to type equal to average. Average is the same as mean, and we're going to select all of these and just hit enter on the keyboard. I'll have the mean to be 1.76. So here we are going to say x minus, sorry, this is equal to x minus, let me just write it 79.17, 79.17. Okay, so take the total of it, fine, and then in the next step we are going to square it. So in this case we are going to just say this, simply multiply it by itself, and then you square it, and then you drag down. Right, so the next thing we are going to do is to then divide this total over 5. So I'm going to say equal to sum of, sorry, equal to sum of all of these divided by 5. I can actually use standard deviation formula to do it. Okay, 9 is the last one. Divided by 5, and that gives us this 173. Let me highlight this in black. Okay, so if I use the standard deviation formula to do it, to calculate the standard deviation of this value, so let's try as the, or let's say variance, so calculate variance based on the entire population, ignores logical values. This one, calculate variance based on the sample. So I'm going to use variance, and I'm going to calculate the variance for all of this, and let's see. So it gives us the same thing. So we have calculated the variance. And remember, variance is the square of the standard deviation. So in this case, I'm going to just calculate a standard deviation for the sample, and this is the sample as well, and that gives us this. And just tell you, if I take the square root of this 173.376, it's going to also give me this. So this is SD. All right, good. So now I have SD, we have xi minus this squared. Okay, so let's see. So let's now calculate. Let's say, let's give a second. Okay, so let's see. All right, so now we are going to write this in the right way. So let me just correct this. This is x, this is x0. So x0 is equal to 70, and our x is equal to the mean we calculated to be 79.17, and standard deviation is given this x standard deviation is given as 173.367, and that gives us SD of 13.17. All right, so the absolute value of TABS is equal to, you can now write 79.17 minus 70 all over the standard deviation of 13.17 times root 6. All right, let's try to work this out. So this is going to give us 9.17 over 13.17 times root 6. And I work it out using a calculator. So let's see. So let me this calculator. Okay, fine. Okay. So I'm simply going to say root 6 square root 2.449 times 9.17 equals divided by 13.17. That's going to give us 1.70. 1.70, right? So we are going to now check this 1.70 against the critical value. So in this case, we have TABS. In this case, is greater than 1.467. All right. So the decision now, as we've said, the decision rule. So we simply decision. We reject. Normally, we don't say reject. We say fail to accept HO, right? So just take note. So this is how to perform hypothesis testing, how to perform t-tests. And this is the step-by-step procedure. I'd like to thank you for viewing. I'm going to stop here, and later we'll look at more hypothesis testing problems.